Okay, so hi there, everyone. I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team and also part of the answer team on AskTOM. I've also got with me today Keith Laker. Keith, are you there? Can you say hi? I can see you there, but he's not responding at the moment. So there you go.
Got it.
Got it. Up you come. Go on then. Can you show us your face quickly and say hi?
Let me see if I can work out. Is that it?
Yeah, we've got you. Fantastic.
Okay, good. Hi, everyone.
Hi. So Keith's the PM for Analytics SQL, so he's in charge of making sure a lot of the stuff we're going to talk about works and help bring new features. Anything you want to add to that, Keith? Or
No, that's pretty much what I do.
Fantastic. Okay, so to start with, what I'm going to do is look at some examples of pivoting and SQL. Before we get into that, just some kind of logistics. If you've got questions, please put them in the chat window. We'll be keeping an eye on that and pick them up as we go along if they're relevant to what I'm saying, or once I've finished, we'll address those at the end. Please keep your questions focused on how you want to use the feature, understanding it better. We're not licensing and pricing issues, then we're not going to cover those either. Talk to your account manager about that. But we're here to help you understand and use the technology more effectively, particularly SQL. So that's what we're here to do today. So now let me just share my screen again, and I'll start by talking about some kind of questions that come up about pivoting. And of course, the basic one is, what is pivoting? And it's about converting rows into columns. So let's just start with the basics. How do you've got data set in rows and you want to convert it into columns? And it's useful to walk through an example when doing this. So what I'm going to use is, I really like running, and I've got my data set of records of when I've been running, how far I went, how long it took me, so I can see, am I sticking with the program, am I keeping up, am I getting better, that kind of thing. And what I want to do is I want to group the data by week. So I've got 3 weeks worth of data here. And for each week, I want to sum up the total distance I've run. So I want to see how far I went in that particular week. And I want to return those as columns. So we can see we got started off pretty well, did 17 miles in a week, and then I'm gradually tailing off. I'm getting less and less involved as it goes on. I probably need to start getting up, running a bit more. So I want the data set, I want to take those 3 groups and convert them into columns that look something like this. So we've got 17, 7, and 1. So let's kind of go back to the dark ages, way back in 10G Oracle database and before. In order to do that, we can construct this manually. So let's think about what we're doing. We want 3 columns, and what we're doing is summing up the information. So we need 3 sum operations, 1 for each week. The question is, what do we stick in these big gaps in the middle here? So we look at the first week. What we want to do is, I've got the data set starts on the 1st of January, and it covers the next 3 weeks or so. I want to see if the running date, the date of the run log, is in the week that starts the 1st of January. And we can do that using this trunk function. And this IW format returns the start of the ISO week, which is the Monday of that week. So today is the Thursday the 8th. The ISO week for the current date is the 5th of March. So that's Monday this week. And we can compare that to see if it is the 1st of January, which is Monday of that week. And if it is, we return the distance, how far I went. And if it isn't, we return nothing. We get null. So we're just summing up the information that matches that. And so that gives us our first week. I then need to repeat basically the same expression again for every other week. The only slight difference is each time I'm changing the date. So I'm looking at a different week each time. So this is kind of easy to say, but some of you are probably looking at that query and thinking it's a bit tricky to see what's actually going on. And particularly if I start adding more and more columns in here, say I want to have 5 or 6 weeks worth of data rather than just 3, it gets really verbose, it's really big. And the only thing that's changing in each week is the date value. So it's a lot of typing for not a lot of benefit, which is kind of thing that as developers, as programmers, we kind of learn quite early on this is a bad idea. So in 11G, we introduced the pivot clause to help simplify this process. So what I'm going to do is just work through like a 3-step process for how pivot works and how you use it. So there's kind of 3 parts to the pivot clause, and I'll work through them from in the order that you write them out in your query. So the first thing you need to define is what is going to go in the new columns. So we have 3 columns, one for each week. The values that go in there is the total distance I've traveled. So I'm summing up the distance. So that's this sum function here. Now note, in general, you will be combining many rows into a single row when using pivots. So this has to be an aggregate function. So sum, count, min, max, average, that kind of thing. Even if you know, for whatever reason, that you will only be taking one input row, you still have to use an aggregate. So you've always got to aggregate those values up. So that's what's going to go in those new columns. Next, we need to define what these new columns are and where those values come from. So where do we get the values that become the new columns? So which is the source? And that was that expression I showed a minute ago, the trunk of the ISO week. So what we're doing is converting the date to a Monday and using that value to say what the new column values are. Finally, we need to actually specify the values. Which values become the new columns? And that's just the 3 dates. So the Mondays are those weeks. So those are a 3-step process. Let's put that into a SQL query, and that would look a little bit like this. So we got the sum of the distance for the ISO week, and we got our dates in here. So this all looks great, but there's a problem. We're going to run it, and we're going to run into a lovely ORA error. Why? Well, you can't actually use an expression in this second part of the pivot clause here. It has to be an identifier. So it has to be an actual column. So what we need to do is take this trunk expression and move it up into our subquery here. So you notice, you see I've got this subquery at the top. This is one of the reasons I like to use it when have a subquery at the top with the with clause when doing this is quite often you need to manipulate the columns or the values that you're going to be using before you can actually use them in the pivot. So maybe you want to convert things to upper normalized dates to weeks or months or something like that. We can move that expression into the subquery, give it an alias, and then we can use that in our pivot clause. So this is nice and good. We've now got a working pivot query. We'll run it, and we'll get an output that looks a little bit like this. And this is the first thing that tends to catch people out with pivot. They look at this and just kind of go, what on earth is going on here? Why have I got all these time in seconds values down here? We got a nice 3 columns we wanted, but why are they not summed up? Why have we got 1 row for each of our inputs still? So let's just look at our query. Now notice we've got the time in seconds in our subquery. Very important thing to be aware of. All the columns or any column that is in your input table, so if you're just passing a table itself or you're passing a subquery like this, that don't appear in the pivot clause, so you haven't aggregated them or they're not a source for the new values, form an implicit group by in your results. And what's really actually happening with pivots is Oracle database is taking this and converting it into that old style sum that we saw in the background. And like I say, any columns that appear in the source table or in your source subquery that aren't in the pivot clause itself become part of a group by, which leads to you getting far more rows than you really wanted. So this is the other reason I really like having a subquery when using pivot. Not only can we help format, massage the data into a format that we're going to use down here, but we can exclude all the columns except the ones we actually need in our output. This is particularly useful if you've got a large table with 30, 40 columns on it or something like that. Chances are you don't want all of those, or you don't want those to be part of your grouping in your output. So you can select exactly the columns you want to get the output you want. So let's just remove that, and it's gone, and now we get the output we want. We get one row for each thing. So that's all very well and good. That's the basics of using pivot. Let's move on a bit and start looking at some of the more advanced things you can do with it. So once we've got that pivot, then a lot of people kind of ask, okay, well, we pivoted one set of values. I've pivoted how far I've run, but what I also want to do is include the total time it took me. So for each week, I actually want to get 2 columns in my output: how far I've run, how long it took me. So we've got many output columns. Now, this is pretty straightforward. All you need to do, so if we've got our data set like this, we've got our distance, I also want to include these totals as well as their own column, which gives us an output that looks like this. So we've got the D, the date, and the time for each one, or the total date, total time. I say, this is pretty easy, pretty straightforward to do. All we need to do is, for each extra column we want to aggregate, just include that in step 1 of your pivot clause. So here we're summing up the time as well. Now note, I've given them an alias here, D and T. This will then be appended to the end of whatever alias we've given to our values here. So we called it week 1, it will be D for distance, and then the other column will be T for time. But also note that we need to have an alias for all except one column, except one of these attributes. So I can have more aggregates here. I might also want to say my average time for the week, my minimum, my fastest time, my slowest time, the max. You have to alias all except one. So that's how Oracle can define the names of the columns correctly. However, I would say that pretty much you would want to alias all of them just to make it clear what's really going on. So we can do that, and now we get the output we wanted. Notice we got the D and the T because they've come from our the alias we gave them, and they become part of our output. So that's all very well and good. Fairly straightforward so far. Next thing we want to do, so we want to convert rows to columns, but you want to do it for many input columns. And again, this is useful to kind of show an example, talk an example here. So what I want to do now is, rather than just pivoting by week, I actually want to say for each week and distance that I've traveled, to the nearest mile. And I want to get the average time it took me in that week for that distance. So we start off and we can see week 1, I did 2 runs which were 1 mile long. Week 1, I did 3 miles which are 5 miles long. Week 2, and so on. So we've actually got 5 groups in our output. We'll have 5 columns, and then I'm averaging these times down here. So how do we do that? How do we get these 2 columns which are going to form our input to give us those columns in our output? So that will give us something that looks like this. So how do we do this? Well, in our step 2 of the pivot clause, we'll see that you put the brackets around it, group them in parentheses, and put whichever columns that you want to become part of your input in it. Then in the values, you need to have a pair for each, a pair of values for each column that you want. Now, you notice here, rather than dates, I've got these values 1, 2, 2, 1, 1, 2, 2, and 3 to mark which week it is in our output. I've done that using dense rank. So dense rank is a function. You sort the values by whatever the order by here is. All the rows that have the same value get the same ranking value. So we had several for week 1. That week starting the 1st of January, they'll all get value 1. Then ones for the next week will all get the value 2, and so on. So these are consecutive values. Rows that have the same value get the same rank. So I've done this mostly just to save me a bit of typing here, and so it all actually fits on the screen. Because if I had to type all these dates out, I could have done that. You can see it would be tricky to see what's going on here. But this has another use, which I'll come back to later. But basically we're ranking by week and then also saying which mile it is. So we'll run that and we get the average time, which gives the output we wanted, like that. So far, so straightforward. And again, you could have many of these. I've done 2. You could have 3, 4, 5. Although, you know, I've seen lots of people ask questions about pivot. I've not seen an example where they've gone past more than 2 or 3 they wanted to pivot by, but it's there if you want it. So let's move on to the final thing that I'm going to cover in the slides today, and that's how do you do this dynamically. So far we've had a static list of dates. We said we want to start on the 1st of January and go for the next 3 weeks. What if instead I want a rolling window? I want a rolling 3-week window of dates. How do we do that? Well, the first approach you can take is to kind of normalize the values you're pivoting to a known values. So saying values way too much there. So if we look at the query itself, and this is where I mentioned about dense rank before, we can select the subset of the data that we want, the 3 weeks in this situation, and then use dense rank to give them the values in the number them 1, 2, and 3, those weeks 1, 2, and 3. And then we can just select out 1, 2, and 3. This makes it nice and easy. It doesn't matter what our input dates are here. If for some reason there's more than 4 weeks, more than 3 weeks, I should say, the 4th week, 5th week, and so on, they'll drop out. We won't see those in our output because I've not included them in the values to pivot. So we want to, and this works really well when you've got a defined list. So you have a specific number of columns that you want to show in your output, but the values that go into them or the values that form them will change over time. And this tends to happen a lot with dates. You might want to have a rolling 4-week window, 3-month window, 2-year window, or whatever. And you just map these values to a specific constant. So in here, 1, 2, and 3, those become the columns. This works really well, like I say, when you know that you're going to have a fixed number of columns in your output, and you just want to map those values to it. Doesn't work so well if you don't know how many columns are going to be in the output. Let's say instead of pivoting by date, by week, what I wanted to do is I wanted to pivot by distance. So, for example, I want to get the average speed I've traveled for each distance. Now, of course, in any subset of the data, there's going to be a whole range of different values there. So the examples I've shown so far only had miles 1 and 5. But even when you round to the nearest mile, over time, I'm likely to have a whole range of different runs over different lengths. So 1 mile, 2 mile, 3 mile, 4 mile, 7, 8 miles, and so on. And exactly which subset the data I select determines how many columns there are going to be. In this data set, there would have only been 2 for 1 mile and 5 miles, but the weeks after, there might have been, I might have done a 1 mile run, 2 2-mile runs, a 5-mile run, and a 10-mile run, which give us 4 columns in our output, or we'd want 4 columns in our output. And this is a bit more tricky, so we don't know in advance how many there's going to be. Fortunately, there's sort of a way around that, and that's to use XML. So the pivot clause has this little XML option, and what this does is it gives you the output in XML format. And this is, you might be wondering why or what the advantage of it here is. Well, you notice I've got this keyword any here in my in list. That means whatever values we have for week here, each of those will become a new element in the XML document. So for all the stuff on our input, we will get a new XML element. I could, of course, replace that with a query instead of a subquery. So I want to say, I want to get these specific dates or dates that conform to whatever rules my subquery defines. And we can do that. And then we get the results as XML. Now, this is where I kind of say it's sort of dynamic or sort of dynamic columns, because you just get one column, which is your XML document. And that will look something a little bit like this. So this can be useful in some situations, but a lot of the time you still want to get this and convert it into, a relational format where you have the particular columns. So you've got to get good at XML manipulation. You've got to figure out how you're going to identify what these values are. You probably need some XML inspection utilities and so on. So this is good in some situations, but it won't work in a lot of situations. However, it's just going to increase the amount of work you do downstream in your client, who has to take this data and turn it into a format people can actually use, or want to use, I should say. So if we want real columns, another option is to use dynamic SQL. And here is where we, in advance, find out which values we want to become columns, or have a query which defines our list of values that we're going to turn into columns. And we can do something like this. So first up, we have a query. We're querying the running log, finding all the distinct weeks, and using listag, fantastic function to convert rows into a comma separated string, and pivoting the results and storing that in a variable. And then we can then stick that in some dynamic SQL, a little bit like this. So we can do that, and then we can open the cursor and we've got the results. So this works, but there is more effort, right? We're now running 2 queries instead of 1. And particularly if, this query here, if running log is huge, let's say it's not just my running logs, but everyone else on the session and whoever is using my app, my running app that I've built, there could be millions of rows in that table. But of course, there's only ever going to be, a handful of weeks, or, so we could be doing a lot of work just to get a few different values out here. So that's a lot of effort. And again, this is something where you need to know your application, know your data, what you're trying to achieve and what you're trying to do, to figure out whether this is the appropriate way to do it. There is one final approach that I wanted to mention briefly. So what you can do is create a pipeline table function, which does this for you. So there's a guy called Anton Scheffer who built a pivot function that does this for you. And what he built is you can take this pivot, take a query, pass it into a pivot function. Notice this is actually a custom function here rather than the pivot clause, because we passed it into the table operator. So he's a smart guy, used the data cartridge extensions for our functions to enable it to do a pivot. Now, at first glance, this might seem better than that dynamic SQL approach because we're only running 1 query, but there's still a lot of overhead to doing this. It's got to parse and figure out what the columns are each time. So it's still pretty expensive to do. So at this point, I'll kind of take a step back and say, well, why do you want to do a dynamic pivot, or a pivot that can have a dynamic number of columns in its output? Because if you're in that situation, you've got to do a lot of extra work on the client, whatever that is, to actually know what those columns are. You've got to have some ability to inspect them, say whether they not exist, and return them if they do. So you're adding a lot of extra work there, which a lot of time you don't necessarily need to do. So often it's better, if you can, to just stick with a specified set of columns and map your values to constants, which you can then place in those columns you defined. But dynamic pivoting can still be useful in some situations. Maybe it's part of a generic library or something like that. Ad hoc queries, again, potentially very useful. So be aware, think about how the client is actually going to consume this if you're going to use dynamic pivoting. So that is all I wanted to cover on, I had to cover on pivoting specifically. So at this point, I wanted to kind of hand over to you. It's your chance to ask your questions. Please put them in the chat. You're free to ask anything about SQL or what we've talked about here. So let me just bring me back up. Anything you want to add on pivoting while we wait to see some questions come in, Keith? Or
no, I don't think so. I think that covered just about everything that's useful. I think the only gotcha which you sort of covered is the concatenation of the column names.
Mm.
And it's quite easy to run out of, in earlier versions, extend beyond the maximum column name when we start to bring together the values that you want to pivot and concatenate the names. So aliasing is a must, really.
Mm.
We will do stuff by default, but as always with defaults, there's gotchas, and that can catch you out if you're not careful. So alias is always alias.
Yes, it's particularly useful if you've got like several functions that are similar and so on, to help make sure you know exactly what you wanted to show and things like that, isn't it?
Yeah.
Okay, so just wanted to say as well, let me just share my screen again briefly. I bring that back up and get my controls again. So I've got a very large blog post where I talk a lot more about pivoting and the reverse, unpivoting, where you've got columns, you want to turn them into rows, using examples of some Olympic data. So there's a lot of information in there. It goes into a lot more detail about what I've just talked about. There's also a lot of examples over on Live SQL. So this is a fantastic utility. This script here is the one that kind of supports the blog post. So if you want to, reading this blog post, you want to kind of follow along, try it out yourself. And of course, my SSO has expired while we've been talking, and it's all blown up. Fantastic. I'll have to go back in again, start again. So it times out when you just don't want it to, doesn't it? It's like, yeah. Okay, so we got someone saying coming in. My internet is all right. ListAg has the limitations on the length. Table contains huge data, then we'll get error. How's this can be mitigated? Anything you want to say on that, Keith? Before
that's a good question. I mean, once you get up to 12C, we'll overcome that problem, but then you run into a subsequent problem, which is that we can truncate.
Yeah.
So now, of course, you run into the problem that you may actually end up missing values.
Yes.
And not getting an error. So then I guess the question was, is it better to get an error and know that you've dropped data, or is it not? And that, I guess, is up to you as a SQL developer to work that one out.
Yes.
I think Tom has a string ag function which doesn't run into this problem.
Yeah.
And there are other ways around that problem as well to generate that list tag.
So there's a blog post which says it's written by you here, Keith, which which
I was going to suggest that one.
So I'll bring it up just so people can see it, and you might get it.
You can get into the data cartridge again to get round that, and the data cartridge will do that. But the new list tag functionality is probably the simplest and the one that's likely to have the lowest impact on performance.
Yeah,
because it's a first-class function written by us. So
yes. So I think as Keith's kind of mentioning, there's he's got this great post here. There are various workarounds available pre-12.2, which all have their own various degrees of clunkiness and problems, depending on how you want to do it. But I think the on overflow truncate clause is a fantastic one, where you say if it's going to blow out the limit rather than get an error, you can just say show some dots and then how many characters you trimmed off the output. But yeah, there's always that fundamental, what do you want to do with that missing data? Did you need to see it or not?
That's the killer, really.
Yes,
we'll happily drop it for you, but it may be something that you wanted.
Exactly. Okay, so does that answer your question, Rajesh, or you got?
Okay.
Yep, it's good. Thanks.
Excellent.
Okay, so like I say, we can. You don't have to. Obviously, I've talked about pivoting here. If you want to ask any other SQL questions, then please do so. I think so we didn't have that many questions come in. I don't think we had any questions come in advance this time like we have in the past. Yeah, you've got a very thoughtful look on your face there, Keith. So.
No, I think pivot, to be honest, I haven't seen, and we don't get a lot of feedback on pivot in terms of support stuff. My impression is, and I think the reason why we put it in is to aid BI tools. So it's more sort of deeply embedded in, things like Oracle Business Intelligence and data visualization tool that we have, etc. Because it is that type of operation where you want to be doing those sort of pivots to populate a grid in Java or something, and you want the data in a reasonable format that makes it easy to populate that grid. So that's kind of the reason why we put it in. I think in sort of generic SQL reporting terms, it may not be terribly well used. Maybe not that well known about.
Yeah, I think there's an interesting point. There's actually a surprising number of questions that come in on AskTOM where the answer involves pivoting, even though it doesn't seem like it would do at first. So there was an interesting one came in actually just 2 or 3 days ago. Someone had a sequence of, I guess, clocking in and clocking out times, but they could have multiple multiple rows which said in and then multiple rows which said out. They wanted to get the last of each of those and show those as columns. So they wanted the in time and the out time. And it's like, okay. So you do a bit of manipulation first to kind of group them, find the last, and then you can pivot them. And there's a lot of kind of situations like that, which it's not immediately obvious that pivot is what you're trying to do. But if you think I've got one column that I want to turn into 2 or 3 in some situations, then actually pivot is quite often the easiest and best way to do it.
Yes, that's true. That's true. I think it's, if I remember correctly, I think in our data miner sort of algorithm building tool, I think pivot is one of the built-in functions. I think from a data mining perspective, quite often where you've got rows, you want to convert those to columns so that you can do more focused analysis on it. So pivoting, I presume for data scientists, is a more used piece of functionality.
Definitely. I think there's a lot of people who are used to their Excel pivot and kind of like
Yes.
And it's all the kind of yearly annual reports where you need to show your sales or whatever by month across the top, and so you have by regions down the side, months across the top, or something along those lines, or days across the top, and so on, which all the financial analysts seem to spend all their day doing.
Yes, yeah. One thing I think we've got another question.
Pivot is appealing because it seems that the code will be simpler, but as you said, it may not be the best performance-wise. In some cases, writing complex statements and aiming for a simple one. Okay, so it's kind of it's always with performance questions. It's always hard to answer in the abstract because there is very few kind of cast iron rules with performance. Like you do this because it is definitely faster. I mean, if you think about it, if one way was always better, the other options wouldn't exist because we would just go like, don't use them. I think one thing, actually, if I just bring the slide up again and let me just share my screen again. So let's share that. If I go back up, okay, so we can see here where I'm filtering the data in the subquery. I think that's kind of a general important point is filter your data as soon as you can, because the smaller the data set you're processing, the less data you've got to work on, faster your query is going to be. So the sooner you can filter your data, the better. And you can actually filter after the pivot. You can have a where clause after the pivot, but in general, if you can, you want to do your filtering here because that ensures that we're filtering as soon as we possibly can. And I think it just comes down to making sure that you're processing the smallest amounts of data as soon as possible. I don't think you've got anything to add to that, Keith, or?
No, I think that, yeah, you're definitely right there. The fewer rows you can feed in, the faster it's going to go. Because as you pointed out before, there is the situation where, if we've got, like we have here, weeks 4, weeks 5, coming into that pivot clause, we're just going to drop them because you're not asking for it. But of course, that's extra work, extra resources that we need to pull that data in and then discard it. So the less work that you can do, the better, really.
Yeah, because if we kind of go back up to the query like here, where I don't have a where clause, if we say there'd been a year's worth of data in here, we still would have, kind of looked at all that and gone, oh, there's 52 weeks, but actually we only need 3 of them. It's we're wasting a lot of effort there. So the sooner you can do that, the better. Okay, so question from Aya. Would you be able to explain about regular expressions? So I think that's always the short answer. Short answer, yes. Long answer, we need a couple of days, I think. No, maybe.
That's a huge topic.
Yeah. So actually,
a good one for another Ask Tom session.
Yes,
they are tremendously powerful.
Oh yeah, they are incredibly powerful. I think it's one of those things. It's like you've got to really think very, very carefully about what it is you're doing, haven't you, to make sure you are matching exactly what you want and nothing else, because otherwise it gets just a little complicated. So what I like to do, there's this site called Regex 101, and you can use this to test your regular expressions. So let's say we've got 1, 2, 3 ABC, whatever, and you can start putting some things in here. So we can look for 1 or more A's, and that will show you what it matches. And I think this is, I use this tool every time I try and type a regular expression. I use this tool and come up with a whole bunch of expressions to see what it can do. So if we wanted to say something like, we want any number, so that would be things 0 to 9, followed by any lowercase letter, A to Z, we can see it matches those blue ones there. Or we could do 1A, 2B, 3D, or and you can see it's slightly color coding them differently, so we can see the extra matches there. And this is absolutely invaluable because you can start doing some some crazy things where you're doing more matches and bracketing them and so on to figure out what's going on. And it's very easy to get lost. I think it's better if you have a specific question. If you've got a regular expression you're struggling with, then let us know. We'll see if we can help it with that. If you're just kind of abstractly asking, you want to learn about it, I think that's something we need to cover in a separate session. Does that sound reasonable, Keith? Like,
yeah. Yes, and of course we've now got overlap with match recognize as well, which will do other pattern matching capabilities.
Yeah,
beyond what Regex does.
Yeah, that's my new favorite feature now. Match recognize. There's there's quite a few questions that come in on AskTOM, and I go, oh, and they say their versions. So match recognize came in 12c. They say the version's 11. I go, so easy with match recognize, but
yeah. Okay. Oh, AQs. Oh.
Is it which one is preferable to use, listener or DBMS AQ register in terms of load on the DB?
Wow.
I'm not sure I can answer that one.
I wouldn't know. It's a long time since I've done any AQ work.
Yeah.
Probably 8i for me on AQ.
Wow. That's that's quite a while. Yeah.
Yeah.
I think the thing is, it's a lot of it's going to depend on how many messages you're expecting to come in, isn't it? You know, in terms of and what the processing is doing once you've dequeued them.
Yeah. Size of message, number of messages.
Yeah, I mean, if you've got something specific that you're struggling with, Rajesh, we could, let us know. We can perhaps find out, but I don't have any general advice on listener versus register at the moment.
Okay. Josh is offering us an example.
He's going to give us an example. Okay, that's cool. Yeah, it's always useful to have an example.
I'm trying to think who the PM is for AQ.
I don't know. I'd have to look that one up.
Yeah, maybe something we have to take offline.
Yeah.
It should be DQ'd immediately.
Okay. And it's
so you're looking for real-time DQing.
Mm-hmm. So there's the call. Is it the callback listener? Is it called? I forget exactly. You can register the PL SQL routine, which DQs them, and I would have to look it up because it's not something I know off the top of my head. But that will read them straight away.
Yeah, I don't know. I don't know. It's too long since I did that.
Yeah. So sorry about that, Rajesh. I think if you can submit questions to these sessions in advance, so if you want to know more details, it's probably better to give a kind of like a complete example of exactly what you're doing and what you're hoping to achieve. Then we can look at that, how that goes.
Oh, there we go. Anil is the PM for AQ.
Anil.
You could wing that over to Anil.
Yeah. Okay.
Good question, though.
Yes, it is a good question. It's queuing is useful feature to help kind of separate your processing. You got something that's going to take a long time. You don't want to force your users to actually sit there staring at the spinning wheel of death.
Yeah.
For it to come up.
Yeah.
Okay. Well, while we wait to see if anything else comes in, so we've got 18C. We can now get it on live SQL and on the cloud now. So can't we? So,
yes.
And I know there's something in your area that's good for this. So we any significant changes in the SOAP web services in 18C? Not that I'm aware of. Have a look on the What's New guide for 18C, I think is the thing to do there. So something, if I can find my share screen button again. I say we've got a whole bunch of examples in live SQL. So as I said, 18C is out, but it's out on the cloud and for engineered systems. So I appreciate that a lot of you either aren't using the cloud and don't have access to engineered systems, certainly not if you want to do this outside of a work environment. So over on Live SQL, we've upgraded this to 18C, and there's a whole stack of scripts in here that you can play around with to see some of the new features that we've got. One of which I think is the thing a lot of people are talking about is our polymorphic table functions. So yeah, do you want to give a quick talk about that? Say something about those, or do you want me to?
I'll let you do it. I'm just quickly trying to see if I can find the SOAP stuff.
Yeah, no worries. Okay, so polymorphic table functions is something that it's been part of the SQL standard, the most recent release of the SQL standard, I believe. And what it does is it allows you to dynamically define columns in your output. So, we mentioned with the dynamic pivot, you can create columns, but this is more about you can also use this. I don't believe, or I'm not sure, I'm hoping we can use this to do a dynamic pivot one day in the future, but I'm not sure it's possible in the current release. But as a little example here, what I've built is a way to take a comma-separated list. So we just skim past that briefly. We can see we've got 2 comma-separated values in the thing here. And make that a bit bigger, and we pass in the columns we want, and we can see it split those out. And it does the same if we got 1, 2, 3, 4. We get 1, 2, 3, 4 columns, and so on. And you absolutely can use this to do a dynamic unpivot. So if you've got an unknown number of columns that you want to convert back into rows, there are examples. I don't think they're not on Live SQL, and they might be in the docs, but there is a way to do that. And essentially, the polymorphic table function has 2 components to it: a describe and a fetch. The describe is mandatory, and that says what your new columns, defines what the new columns are going to be. And then the fetch, although it's optional, you probably will pretty much always want to use it to pass the values into those new columns, define what those new columns are. So in here we can see we're reading these new columns in. I'm doing a whole bunch of horrible substring type stuff, and that gives us our output. And finally, you create the pipelined row or table polymorphic function like this. And this is the one that you actually call in your SQL statement. So we see we've got CSV columns there. That goes in there. And this here, you'll notice, is actually the table name. So we're really just passing a table into the function. It's reading the data out of that, and depending on what we've done, how we've defined it, it will then add some columns, remove columns, and manipulate the output to do that. So there's various things that were suggested in the SQL standard to do this. Dynamic unpivot is something I mentioned, a CSV to columns or something along those lines. But I'm sure a lot of people out there are going to come up with some creative and interesting ways of using this. So have a look. And they say, if you want to fiddle around with 18C, just see what features are there. Take a look, do the search on the code library. You can see we've got a whole stack of scripts available. You can fiddle around, try your own things. Unfortunately, there's actually quite a few polymorphic table function examples someone else has put in now. Yeah. Unfortunately, Live SQL doesn't support external tables, which I think is a shame, because I love them. They're a great way to read tables, files into your database using SQL, and also doesn't allow us to show one of the new features where you can have an external table on the fly. So you don't actually create a real table, you just do a select from external and then define the whole table in your query. Very, very handy when you're trying to build it in the first place. Quite often when you're developing an external table and it's not a straightforward CSV, it's really fiddly to figure out exactly, how you've got to define your parameters to get it to work. And again, also exceptionally handy if you are a data scientist or someone else who regularly has to pass logs or read other data from all sorts of who knows what format, and they're just trying to figure out how to actually extract anything useful out of it. So I think that's a great way to do that. Anything else you want to mention on 18C, Keith, or those features?
No, I think PTFs is probably the big one.
Yes.
And I will get around to looking your pivot code.
Yeah, like I say, I'm hoping that there will be a way to do the dynamic pivot using PTFs. I can't figure it out. I can't figure out if I'm just not spent enough time with the feature yet, or if it's something that we'll have to wait for a future release for.
Yeah, I need to look at the code. I can't remember whether we had the row reduction logic in there or not yet. I need to confirm or disprove it. So I will get onto that at some point.
Yeah, exactly. Okay then. So I haven't seen any more questions come in. We've been getting close to the hour. Oh, someone else. Oh, one more. But any plans to release Oracle Forms 18C? I have no idea on forms, to be honest. I'm not the right person to ask about that. I don't know if you've got any insight.
No, I think that would be Duncan. Duncan Mills probably would be the best person to answer that.
But I don't know. Well, I think now we're moving to these kind of annual releases, and I believe we're supposed to be doing it for pretty much all our products, certainly the database related ones. So on the one hand, I've not heard about it. On the other hand, whatever the next release of Forms happens to be, probably would be 18C, maybe 19 if it doesn't come out this year for whatever reason. But yeah, no insight on that, I'm afraid.
No.
Okay.
As I say, we only do back-end stuff. We don't do front-end stuff.
Yeah, exactly. I'm a data guy. I don't care about a user interface, things like that. There's someone else to sort out.
Yeah, I think if you can track down Duncan Mills, Duncan's the person who's your forms guru.
Yes, that sounds right. Okay. All right then. Unless anyone else wants to ask a question, I'll wrap up briefly. So really hope you enjoyed this, found this useful. Whatever you thought of this session, we'd really like it if you come back to the office hour session, and somewhere on it there is the ability to give feedback, because we want to help you. We want to make sure you can use the technology effectively, help solve the business problems, improve your skills, get better jobs. We're here to help support you to get the best out of the technology and help you have a fulfilling career. So we want to ensure that these sessions are useful and relevant to you, and you get what you want out of them. So if you register, I think you need to sign up first, then you will have a feedback box where you can go in, let us know how we've done, what we could do better. We've got a whole bunch of other office hours sessions coming up, covering a whole range of topics. We've been about SQL specifically, but there's things about security, JSON, multi-tenant, and so on. If any of those are relevant to you, find them useful, take a look, please sign up. These are regular, ongoing. If you're stuck, just drop into them, ask us your questions. Anything you want to add before we close out then, Keith? Or?
No, that's been pretty useful. Good questions.
All right then. Well, thanks for joining me, Keith. Thank you everyone for joining us on the session. I hope you found these useful, and we'll see you again next time. Thank you. Goodbye.